This video is sponsored by Envato Elements. Hey everyone, and welcome back to another very exciting Blender tutorial. In this video, I want to show you how to create this effect using geometry nodes in Blender. It's based on the geometry proximity node, which we're going to go over in this tutorial. But as always, if you either want to skip all of my waffle or you just want to play with the final project file, you'll find download links to the final file as well as timestamps that will jump you straight to the tutorial down in the video description. Now, one important thing to note is that this is part 2 of my Geometry Nodes Blender Beginner series, and I will assume that you have watched the first part before you jumping into this one. Also, if you're completely new to Blender, I have a beginner tutorial series for Blender, and again, I'm going to drop you the links to all of those playlists down below. But as is my style, I will usually go fairly slowly and explain everything in detail, so hopefully you shouldn't have too much problem following along. Now, first off, I'll show you how to create the actual disintegration effect itself. After that, I'll then show you how to create this proximity effect within your geometry node setup to create this effect of the monkey head disintegrating as the sphere gets closer to it. And just a reminder to use the timestamps below to jump to any part that you might find interesting. But first off, I want to give a big shout out and thank you to Envato Elements for sponsoring this video. Envato Elements is a massive online resource offering over 55 million digital assets to kickstart your next creative project. They have everything from graphic and video templates for your favorite tools such as Premiere Pro, After Effects, DaVinci Resolve and others, to stock footage, graphic elements, music tracks, sound effects, 3D models, fonts, website templates and a ton more. They offer a really simple licensing model that gives you full commercial rights to any asset you download, with some reasonable clauses like you can't resell them of course, and that license remains valid even after your subscription has ended. You can sign up to either a monthly or an annual subscription, both giving you access to an unlimited number of downloads across all of the assets, and I'll drop you a special link down in the video description that will give you 50% off if you choose the annual plan. And if you're unsure, why not sign up for a free account? You get 12 free assets every month and you can upgrade your account at any time you want. But now I feel like I've really waffled on forever. Let's finally jump into the tutorial. Welcome to Blender, and this is the final effect that we will be creating. You can see that whenever the sphere gets anywhere near the monkey head, all of the geometry of the head itself gets disintegrated, pushed down, kind of looks like it's exploding near the sphere. So this is using that proximity effect. Now it looks like the inside of the monkey head is glowing, and that's because there's actually a light in it. If you come up into the options here, enable extras, you can see there's actually a light in the middle of the monkey head, which gives it that really nice glowing effect. And as I mentioned before, you will be able to just download this file from our website. So simply go to surfacedstudio.com/downloads, and you'll find all of the links down in the video description as well if you want to just grab the file and work with this. But let me just get my ugly face out of here and let's get started. First off, I'm going to select the monkey head as well as the sphere, press X to delete them. And by the way, you'll see all of the keyboard shortcuts down here in the bottom left faded in as well if you're wondering. So now let's add our own monkey head into the scene. And let's just move it up a little bit so it sits on top of the ground. And you can see that that bright light is now inside the monkey head. So once we explode all of this, it'll look really cool. So now up at the top, let's come into the geometry nodes workspace. Let's select the monkey head, and you can now come into the modifiers and add a new geometry nodes modifier. But with the model selected, you can also just press new down here in the bottom in the geometry nodes editor. That's going to create a new geometry nodes modifier, already applied to the selected model, and then we're all set up to go. Now, the first thing we need to do is we want to offset and reposition the faces of this monkey. So we will probably need a node to change the position. For that, Shift and A to add a new node. Let's come into search for position. And I want to drop in this set position node right here. I'm going to drop that right in the middle of our geometry flow. And now if you play with this offset, well, we're just moving the entire mesh around because we have not broken this model down into individual faces. Fortunately for that, there is another node. So Shift and A, let's add another node into our geometry node tree. Let's go to search and let's search for the split edges node. Let's select it and drop it right at the beginning before the set position node. Now nothing has changed. And if you now twiddle with this offset, we're still moving the entire monkey, and that's because the same change, the same set position operation gets applied to all of your faces and all of the vertices, and therefore the entire model as a whole. What we really want to do is we want to offset all of the individual faces differently. And for that, let's connect an input into this offset property here. And for that, there's actually a really nice shortcut in geometry nodes. So let's click onto this little diamond here on the offset, which is really a function input parameter. If you remember from the first part, let's drag to the left, let go. And now the search comes up automatically because Blender is now expecting us to connect a node as the input into the offset. Let's search for random value. Click on that, drop that down, and you can see it's automatically connected to that offset property. So that just makes it nice and easy. And our monkey has completely exploded and looks like a giant hedgehog, to be honest. Now, you'll see something really weird happen, and that is that all of the faces look really distorted and twisted, and just it doesn't really look like the geometry of the monkey anymore. And the reason for that is that set position is applied to every point, to every vertex individually, not to every face. However, we want to have the position for every face randomly offset and that face to kind of retain its integrity and its structure. For that, we actually need to be a bit more clever. So let's make a little bit of space here after this split edges node. And if you look down onto the random value, there's this ID input property here. This is an integer value, like a whole value, that determines which random value to generate. If you feed the same ID in for all of the vertices that sit on the same face, the random value, the offset for those vertices that are on that same face will be the same. However, if you come into the spreadsheet up here and select vertex, on the left hand side you can see the ID, and every single vertex has a different ID. Therefore, every single vertex gets a different random value and therefore a different offset position. If you select the faces, they have an ID too, and we need to get this ID captured and fed as an input into this ID property on the random value. For that, there's a really useful node called capture attribute. So with the cursor over the geometry nodes editor, shift and A to add a new node, come into attribute, and in here you've got the capture attribute node. Let's select that and drop it behind our split edges, because only at that point do we actually have individual faces. So let's make a little bit of space. And we want to capture the ID. Now the ID here on the left hand side you can see is a whole value. It's an integer value, so let's change this top drop down from float over to integer. We don't want to capture this attribute of every vertex, so we don't want to go by the point. We actually want to change this over to the face, so that the integer value that we're capturing of the face is this one here. It's this ID value. However, right now Blender doesn't know what capture attribute should actually capture. Which attribute do you mean? Is it the normal, the material index, the shade smooth property, or anything else? We need to feed something into this capture node attribute to tell Blender to capture the ID specifically. For that, at the bottom you've got this value. On the left hand side again we can connect a function. So click on this value, drag to the left, let go. Let's search for the ID property. And by the way, if you just can't find it in here, sometimes this search gets automatically updated and you may not be able to find what you're looking for. So if that happens, just shift and A, come into the input category and select the ID. Drop that in here and just make sure that that's connected into the value. So now we're telling Blender to capture the ID from every face on our geometry. And now this node has an output for that particular attribute. So what we now need to do is we now need to feed this attribute down into the ID property on the random value, and keep an eye on what happens with the monkey over on the right hand side. Let's just drop that in. And now all of the faces are still intact, because now whenever set position looks for a random value to offset a point, the ID used to generate that random value is based on the ID value of the face, and therefore all of the points that belong to the same face get the same random value and the same offset, and the geometry of the faces doesn't fall apart. I hope that makes sense. It's a little bit more complex, but the capture attribute node is super useful and we will be using it quite a bit more throughout the remainder of this tutorial. So hopefully that explanation was somewhat understandable. Now, right now, all of our faces are offset by a minimum of 0 and a maximum of 1. Obviously, we could change these values here, but again, we kind of just want to have a parameter on our geometry nodes set up so we can just control the amount of disintegration that happens on this monkey. And just like in part 1, let's press N with our cursor over the geometry node editor to bring up the panel on the right hand side. Let's add an input. Type float is fine, but let's rename this to disintegration. Minimum should probably be 0, maximum infinite. Sure, why not? And now on our group input, we've got this disintegration input right here. Let's grab the input of that and let's connect it to the maximum. Let me just grab a couple of nodes here. I'm just holding down shift to select them all and just shift them up just a little bit. And let's feed the inverse of this disintegration value into the minimum. For that, let's add yet another node and let's use our beloved math node here. Disintegration goes into the top of the value. Going to change this over to a multiply and multiply that by -1 to invert that value. And then the negative value can go into the minimum. Let's rotate around our monkey just a little bit. And now in our geometry nodes setup in the modifiers tab, if we jack up this disintegration, you can see our monkey slowly disintegrating. Now, this is not a bad effect. However, you may notice that all of these faces are kind of just randomly offset. They some of them shift inside, some of them go to the side. And wouldn't it be much nicer if all of these faces kind of push out along their normals? So it kind of looks more like the monkey is exploding outwards in all directions. Fortunately, we can do that by, again, capturing an attribute of the face, the normal, and then using that to control the direction in which all of these faces are offset. For that, let me just make a little bit more space on the right-hand side here. Press N to just hide that panel just so you can see this just a little bit clearer. I'm just going to make this a bit bigger as well. Now, we want to offset this position by the normal of the face. If you go to the spreadsheet editor, you can see that every face has a normal assigned to it, and that is exactly the attribute we want to capture and then use within our graph. And for that, you've guessed it, we're going to use another capture attribute node. So Shift and A, we want to search again. Let's search for capture attribute node. I'm going to just drop that right here after my first capture attribute node. This time the type I'm going to capture is a vector, because the normal is a vector with 3 components, X, Y, and Z. Again, I want to capture that property of the face. And on the input value, again, click and drag to the left to get that little quick help connector. Let go. Let's search for normal, and I want to drop in the normal as the input. So the output attribute here now is going to be the normal of that face. If you grab this attribute output and connect that into the offset, well, that kind of looks like an exploded monkey. All of the faces are pushed outwards along their normals. That's pretty cool, but we've lost control over how far they get pushed out because, well, we've kind of disconnected the multiply and the random value node down here. However, we can easily scale the normal vector however we want to. For that, there's a vector math node, which works similar to the math, just on vectors. So Shift and A, come into search. Let's search for vector math. Let's drop that in. I'm going to drop that right on the connection here between the attribute that captures the normal and the offset on our set position. Let's just drop that in. I'm going to change that over to scale. And now this scale property here controls how far those faces are being pushed outwards. And yes, you can go negative as well. But let's just take this disintegration property from our input. And rather than going through the multiply and the random value, let's just grab that and stick that right onto the scale up here. So now this disintegration property that we have on the node controls how far these faces are being pushed out along the normals, and this looks much nicer for a disintegration effect. However, the tutorial is about proximity, and we haven't even talked about proximity yet, but that is what we're going to do next. Wouldn't it be great if we can control how far these faces are being pushed out by how close they are to another object in your scene? And we can do that with the geometry proximity node in the geometry nodes. First off, let's create an object in our scene that when it gets close to the monkey face, it'll start pushing out and exploding all of those faces. So with your cursor over the 3D view, Shift and A, let's add another mesh. I'm going to just add a UV sphere into my scene. G, let's move that up. S, and scale it down just a little bit. I'm just going to move it to the side here of the monkey face. Maybe I'll make it a little bit smaller. Let's reselect the monkey face so we can get our geometry node graph back down here at the bottom. And you can pull in this sphere automatically into this graph. However, I prefer just adding it as an input into this graph itself. So again, let's press N to reveal the properties tab on the right hand side. Let's add another input. Let's rename this one to force. And I'm going to change the type from float over to object. I actually want an object input into my graph. Over on the right hand side in the geometry nodes properties, I now have this force input, and I can now select the sphere that I created, which is this sphere here. By the way, we should probably call this something slightly different. Let's just call this force and select the monkey. Make sure, yep, that is selected our force geometry object. In the geometry nodes tree, on the group input, you now have this force input, and it's orange because it represents an object. Now the node in geometry nodes that we want to use to calculate the proximity is, no surprise, called geometry proximity. So let's add it to our graph, Shift and A, come into search, and simply search for proximity. And there's geometry proximity node here. I'm just going to drop it over on the right-hand side. I'm just going to collapse the multiply and random value nodes for the time being and just move them down. We'll utilize them a little bit later once again, so I don't just want to delete them. Now, geometry proximity takes a target in, and that's green because it needs to be actual geometry like vertices, faces, and edges. It can't be an empty object because an empty object doesn't have geometry. So if you're using proximity, make sure you have an actual geometrical object like a sphere, cube, or anything else. Just don't use an empty for that. Now, this target is green. So if you now take this force object here and try to connect that to the target, that'll go red because force represents an object input and the target is expecting to be geometry. So we need to put something in the middle here to make this work. And what we need is the object info node, which gets all of the properties of an object that you might have fed into your graph. So Shift and A, come into search, and let's search for object info. And let's drop that right in the middle onto this big red ugly line here. And Blender is happier, because the force object now connects into this object input on object info, and this breaks it down into location, rotation, scale, and geometry. And the geometry of this object, of this sphere that we have here, then feeds into the geometry proximity node. This then outputs a position, which is the closest position on the target geometry, as well as the actual distance between the two. So let's take this distance and connect that into our scale for scaling up those normal vectors. Let's let go. Well, something happened. Let's grab the sphere, move it around, but that doesn't really have an impact. Let's reselect the monkey head. And the reason moving the sphere has absolutely no impact is because we haven't fed anything into the source position to calculate the distance from yet. For that, again, we need to capture the position attribute of a face. And how do we do that? With another capture attribute node. See how useful they are? They just come in handy everywhere. So let's once again make a little bit of space over on the right-hand side. I might actually also drag the object info and geometry proximity over a little bit more. And let's add yet another capture attribute node into our graph. So Shift and A, search, capture attribute. Let's drop that in here. This time we want to capture the position. The position again is a vector. And again, I want to capture it of a face. And the input into that value property, let's just drag this down, is going to be the position property. So again, it's going to extract the position property from every face and output that into this attribute here. And yeah, again, let's just pull this over a little bit more. And this output position of the face is now what I want to push into the source position down here. So let's grab this attribute output and connect that into the source position for the geometry proximity. And something happened. Let's reselect the sphere, G, and let's move it around. And again, nothing happens. So let's let go, reselect our monkey. And the reason for that is that down in our object info node, we've actually set to use the original transform, not the relative distance between the two. So it doesn't actually get updated when you move the sphere. So let's select relative here. Whoa, our monkey just exploded. So that looks a bit odd, but let's reselect the sphere one more time, G, and let's move it around. That looks like we actually have something happening. So if I move the sphere kind of to the center of the monkey head, it doesn't look all too exploded, but you can see that it's actually inverse. The further the sphere is away from our monkey, the further all of the pieces explode now. So that's kind of what we want. It's just the wrong way around. So let's reselect our exploded monkey head. And what we need to do is we need to remap the distance that we're getting out of our proximity. So it works the other way around. And the easiest way to do this is with the map range node. So Shift and A, search. Let's search for map range. And let's drop this in between the distance and the scale input so that we can control how the output, the actual distance calculation value, gets mapped and applied to the offset of our normal vector. By default, nothing much will change. We're just mapping 0 to 1 to 0 and 1. But I actually want to inverse the 2 min and 2 max from 0 and 1 to 1 and 0. And now this looks much more like what I would be expecting. Let's grab the sphere, press G, move it away. That is kind of what I'm wanting. So now as I push the sphere closer and to the side, you can see how it's affecting and pushing away any faces on this monkey that are nearby. So this is much more what we're expecting, where we can explode the monkey based on the proximity to the sphere. Now you can easily control the influence of the sphere either by scaling it up or down, because the distance gets calculated based on the actual geometry of the sphere. But if you reselect the monkey head, you can also play with this map range node. So let's maybe bump the max up a little bit so the influence range is just a little bit further, maybe 1.5 or so. Maybe I'll lower the minimum a little bit as well, just to tape us off a little bit nicer. Now this is still just a linear remapping. You could add curves and other things to, get more of a gradual fall off of this particular effect. But I think that as a base effect actually looks pretty cool. Now, one thing that unfortunately we have lost is that this disintegration parameter here on our geometry nodes, if you change that, it has absolutely no effect, because if we look at our geometry nodes graph, that disintegration value just goes to a random value that we're not really using. So what I actually want to do is, wherever we're scaling our vector here, into this scale value that comes out of our proximity, I want to multiply that in. So once again, let's add our beloved math node into that. Let's change it from add over to multiply. And let's grab this disintegration property here, drag it over to the right-hand side, and stick that into the other side of that multiply node. And yes, it's getting a little bit messy. There's quite a few things that you can use in Blender to control this better and kind of change the way the lines flow, but I'll include that in another tutorial. For now, we're just gonna live with the mess here. And now, in our geometry nodes modifier, if we now change this disintegration, we can again control the impact or the influence that that sphere has as it gets closer to the monkey. Maybe just a little bit too low. Maybe I'll jack it up to maybe around 1 or so. Just I want a fairly noticeable effect as that sphere swipes past the monkey head right there. And then the last thing, if you grab this node and move it to the left, all of this is very, very symmetrical. There's no randomness and it's a little bit static. We can add a little bit more interest to that by, again, utilizing the random value that we kind of already have calculated down here. Again, based on the face vertices, so all of the points on the same face will receive the same random value. And the easiest way, again, let's just multiply that right back in. So either pop it before or after this multiply node here, but I may not want to reuse the same disintegration value here. So on the inputs for our group, let's add yet another input. I'm actually going to move this up by 1, change this over to be a floating point type. Let's rename this one to randomness. Let's come in here, let's expand the multiply and the random value nodes again. And rather than using this disintegration, Control, right click and drag to cut those ones off. And I'm not going to use this randomness here and just drag that into the top of the multiply, as well as the max on that random value right there. And again, remember that the ID still comes from the face itself. So every face will get the same random value rather than every point. And let's take the output of this random value here and multiply that right in there. So Shift and A, search, another math node. Drop that onto our input disintegration line. Now, I don't actually want to change this to multiply, I just want to add some randomness. So let's leave this on add. Let's grab this output of this random value and stick that onto the other side. So if we now look at our monkey and jack up this randomness, you can see how that just adds a little bit of variation. Maybe I'll just give it a randomness of 1, 1.5, just a little bit of variance between all of the different pieces. So it just doesn't look quite as symmetrical. So that is pretty cool. Let's return to the layout tab. Make sure you're in rendered view, and I'm just using Eevee to render this out. We've recreated the effect from the beginning of this tutorial. So now you have this really nice proximity disintegration effect, and the geometry proximity node in Blender is super useful. You can create some really funky stuff with it, and go and check out all of the awesome stuff that you can find on social media, Reddit, Twitter, Instagram. There's a lot of cool stuff that people have done with it. But hopefully this gives you a good understanding of how this node works and how you can leverage its power in your own geometry node setup. And that is all there is to it. I really hope you enjoyed this tutorial, and please don't forget to like and subscribe if you would like to see more. All and any useful links you will find in the video description, and please leave any comments, questions or suggestions down below. And with that, thank you very much for watching, and until next time, I will see you later.